What's poppin', dogs? It's Mr. Allen, and in this video, we're going to go over how to determine if two triangles are similar. And then we're going to state why they are similar, if they are indeed similar, and write a similarity statement. And being able to write similarity statements are super helpful in other problems you have to set up proportions and things. All right, first one here. I've got ABC, and we got DEB, or whatever order we might need to do here. Two different triangles. Are they similar? I see two right angles here, so we got a pair of angles that are congruent, but I see nothing else. Wait a sec. Aren't these vertical angles, which are always congruent? Therefore, these two triangles are similar by angle similarity. All right, that's shorthand there for saying similarity. That's what we'd use for our similarity statement. So angle similarity. We only need two angles to have this happen. Angle is just, overkill on that one, right? Because if I got these two angles congruent and these two angles are congruent, these two have to be congruent based on the angles adding up to 180 degrees in a triangle. So there we go. We know they're similar. Now I got to write a similarity statement. The way I like to write similarity statements is I start with one triangle. I'll just go A, B, C. So A, B, C is similar to triangle. And now I need to line up the angles of this triangle with the corresponding ones of this triangle. C and D need to be in the same spot. Therefore, the last one needs to be D here. B and B are going to need to be in the same spot, which just throws E in the spot where A was, right? So A and E, we actually know that those are going to be congruent. It's called the no choice theorem, some call it. I'm sure there's other names out there for it as well. But A and E need to be congruent. C and D we know are congruent. B and B, or A, B, C, and E, B, C had to be congruent. So there we go. Got our similarity statement. That allows us to set up proportions and solve for sides and other problems, which is super awesome. All right. Let's keep it moving, man. Let's keep it moving and grooving. I'll go orange on this one. So over here, I've got myself a couple pairs of sides and an angle, and that angle is included between those two sides. So perhaps we have a side angle side situation here, but we do need to check it, okay? My corresponding sides here appear to be the 9 and the 6. I'm going to write that down. 9 over 6. Is that equal to 12 over 8? It's interesting. Well, that would simplify down to 3 over 2. That would simplify down to 3 over 2. So yes, the sides are proportional. And we've got one pair of congruent angles. Therefore, this is side, I'll put it up here, side angle side similarity. All right. Cool, man. So we know that those are similar by side angle side similarity. Now let's write out a triangle similarity statement. I'll start with ABC again. A, B, C. And that's going to be similar to, it's honestly tough with sides at times, but I know that A and D have to line up. So I'll start with D here. And then AB, this side here corresponds to DE. So if it's AB is the first, then it's DE, and then F is the only other one that we have, okay? And let's double check. AC should line up with DF. AC is on the outside, DF's on the outside. This all looks Gucci. Okay, cool, man. Keep on rocking and rolling. Similar triangles. Let's see what we got here. So for this one, it appears to be kind of the same situation, right? Where we might have side angle side. So let's check that out. It looks like 20 and 10. Those are my two biggest sides. I'm going to pair those up. So 20 over 10. Does that equal, the other two are 8 and 5. So 8 over 5. Well, this simplifies down to 2 over 1, or just 2. I'll leave it as a fraction. This cannot simplify. So these two are not equal. You can also see this with cross multiplication. Does 20 times 5, which is 100, equal 8 times 10, which is 80? No. So not similar. And you usually have to show some kind of work like that to justify why they are not similar. We only have one angle pair, so not enough to do angle similarity. That's about it for this one. All right. Next one. Last one. We have 3 sides known for each triangle. So side similarity is the only possibility here since we have no other information. Let's see if we can get this done. So we'll have the smallest sides paired with the smallest and largest with the largest. I'll start with the largest. 8 and 4. So 8 over 4. Then we have 6. That should pair with the 3 if this is all going to work. And then 4 with the 2. Oops, equals 4 over 2. So this simplifies down to 2 over 1. As does this. So far, so good. And that one as well. Excellent. All right. So this triangle here is, twice the size, a scale factor of 2, if you will. So they are similar by side similarity. It's a terrible similarity. Yeah. Ooh, I don't like it. I don't like it. Let me see if I can get it erased. It's a little tough on these boards here. All right. That's kind of better. All right. I feel better about that now. I feel better. Okay. Now let's write a similarity statement here. So I got triangle ABC I'll start with the first one. And then that's similar to, hopefully it's just alphabetical order. Let's see here. The smallest side is AB, which would correspond to DE right here. So DE has to be this spot. And then BC is the biggest side, which would go with EF. So BC, EF. Looks like it's definitely right. Get it? Dope. And then we also have DF over here. Should pair up with AC. DF's on the outside. AC's on the outside. Everything looks fantastic here. Well, there you go, guys. If you're asked to state if two triangles are similar or not, using any one of these three, postulates as we call them, then you should be ready to rock and roll after this one. So thanks for watching. Make sure you guys watch some more. Hit the like, the subscribe. Tell your friends, your family. Everybody loves doing math, right? Everybody loves math vids. So keep on watching and have a great day.